Okay, so this video is going to be on the introduction of right triangle trig. Okay, so before we can start solving things or using trig, we need to talk about, well, what does a right triangle look like? Okay, so here's a right triangle. The reason why I know it's a right triangle is because we have a right angle. So this angle is 90 degrees, right, which is a right angle. Okay, so that's how we know that this is a right triangle. Okay, now this right triangle has a few parts. Okay, the first one is the hypotenuse. Okay, so this is the side that is directly across from my 90-degree angle. Okay, so that's my hypotenuse. Okay, then the other two, the adjacent and the opposite, all depend on where this angle is. We call this theta. Okay, so based off of this is where we get these two sides. So adjacent, right, this is the one that runs along our theta. Okay, so it's right next to it. Okay, then opposite, the opposite side, is the one that is right across from our theta here. So right across our opposite angle, that's our opposite. Okay, so those are our parts for a right triangle. Now when we're solving missing things in a right triangle, we have three operators to help us. Okay, these are sine, cosine, and tangent. Okay, now these are just three operators, so kind of like logs from the last unit, they're just operators. Okay, so we use these to help solve triangles like this. So solving for theta or solving for missing sides, we're going to use these three things here. Okay, so let's kind of break down what these three things are. Sine, cosine, and tangent are ratios of the sides that help us find theta. Okay, the missing angle. Okay, so before we can get into actually using these, we're going to talk about something that will help us out. Okay, and this is SOHCAHTOA. Okay, and this is a way we can memorize or make it easier to memorize, well, what are the ratios for each of these? Okay, so let's start with sine, this one right here. Okay, so sine of theta, right? Theta is our missing angle, the one we're trying to solve for. Okay, so this stands for opposite over hypotenuse. Okay, so this is going to be equal to opposite over our hypotenuse. Like that. So that's our ratio for sine. Okay, and then the other two are very similar. Okay, so ca, with our c, we know we're using cosine. So this one comes cosine of theta, right? We're trying to find this missing angle here. Okay, and this stands for adjacent over hypotenuse. So this is equal to adjacent over our hypotenuse. Okay, and then our last one, the t stands for tangent. So tan of theta. And then this one is opposite over adjacent. So opposite over adjacent. Okay, so we can use this acronym here, SOHCAHTOA, to help us memorize what these trig ratios are. Okay, so let's see how these work in an example. So let's say I have a right triangle. Like this one. I know it's right because I have a 90-degree angle here. And let's say this side is 3, this side is 4, and this side is 5. Okay. And for this one, let's say our theta is right here. Okay, so a little different from that first example, but we just go off of where our theta is. Okay, so the first thing I want to note is that this is our hypotenuse. Okay. Okay, now we go off of theta to find our other two. So our theta, well, this one is across the opposite side from our theta, so this is our opposite. And then the next one is the one right next to it that runs along it. That's our adjacent. So now let's find all three of our ratios, our trig ratios. So let's start with the sine of theta. So what is this equal to? Okay, well, sine, remember, is so opposite over our hypotenuse. So, well, what's our opposite? Well, we said that is 4 over, well, what's our hypotenuse? 5. So sine of theta is equal to 4 over 5. Okay, so let's try cosine of theta is equal to, okay, well, cosine is adjacent over hypotenuse, right? So adjacent over hypotenuse, okay? So our adjacent was 3, so we write 3 over, well, what was our hypotenuse? 5. Okay, so the cosine of theta is equal to 3 over 5. And then the last one is tangent of theta. Okay, this is our TOA, so opposite over our adjacent. So our opposite is 4. Our adjacent is 3. Okay, so the tangent of theta is equal to 4 over 3. Okay, so now let's talk about, well, how do I solve for theta? How do I find out what theta is? Okay, so let's say we have this first one. We have sine of theta is equal to 4/5. Okay, well, how do I find theta? Okay, well, I have this operator here that I need to get rid of to get this theta by itself because I'm solving for theta. Okay, so just like our last unit with logs and exponentials, well, what did we have to use to get rid of that operator and solve for our variable? We had to use the inverse. Okay, so we're going to do the same thing here. So to get rid of this, we take the inverse of sine, which is inverse of sine. Okay, so by taking the inverse of this, we get sine by itself is equal to, well, whatever we do to the left side, we have to do the right side, sine inverse of 4/5. Okay, so let's back up here. So we're taking the inverse of sine, okay, which gets rid of the sine, leaves me with my variable, my theta, but whatever I do to the left side, I have to do the right side, so I have to take the sine inverse of this side right here. Okay, so now I go over to my calculator. Okay, I'm going to take this inverse of sine, that one right there, plug in 4/5, 5, and equal to, okay, so I get theta is equal to around 53.3 degrees. And there's my theta. Okay, well, what about cosine? So this one we had cosine of theta is equal to 3/5. Okay, same idea, except now we're just dealing with cosine. Well, how do we get rid of cosine? The inverse of cosine. So we take the inverse of both sides, so the inverse of cosine, and then do the same thing over here. So we're taking the inverse cosine. Okay, well, this gets rid of my operator. I'm left with theta is equal to the inverse cosine of 3 over 5. Okay, now I go to my calculator right here. I find my inverse cosine button, 3 over 5, and I get theta is equal to 53.13. Okay, and then the last one, we have its tangent of theta is equal to, well, what was our ratio? 4 over 3. Okay, Now, same pattern as the other ones. We use the inverse of tangent. The inverse of tangent. Okay, well, that gets rid of this operator here. Then I'm just left with theta is equal to inverse tangent of 4/3. Okay, so I go to my calculator, find the inverse tangent there, 4/3, and I get 53.1. Okay, so a few things to note here. Well, what are we finding? Well, we're finding an angle, right? So all of these need to be degrees. Okay, so we're talking about degrees. We got to make them degrees. Another thing to note is notice I got the same exact answer for all three of them. Okay, so when we're solving for this theta, it does not matter which trig ratio I use. As long as I use my right parts, so sine, remember, so opposite over hypotenuse. Okay? Cosine, adjacent over hypotenuse, and then tangent, TOA, opposite over adjacent. Okay. So that's how we solve for theta using sine, cosine, and tangent.